Okay, evidence for plate tectonics, explore number 2, uh, unit 3, concept 3.2. Okay, discovery, education, living Earth. Go ahead and write that down, put your date in. What evidence supports the theory of plate tectonics? Take a moment, tell me what you know. All right, so your text starts with Wagner's evidence for continental drift. Um, the theory of plate tectonics is relatively new. This is important. I'd like you to just appreciate how recent this has been accepted. Just in the 1970s, Wagner was around in the early 20th century. And he wasn't the first person, if you recall from some of the videos in Discovery, he was not the first person um, to think about tectonic plates, the idea that continents might not be in the same position they were in the past, that there might have been a Pangea. But he did manage to kind of put some of the pieces together, literally. He, of course, argued that the continental coastlines fit like puzzle pieces. Some are easier to see than others. For example, as you know, when you look at South America and Africa, those pieces seem to fit quite nicely. Um, some of the other evidence that he found was that you had similar landforms that span across the oceans. They're located on different continents, this similar landforms. And let's just kind of make sure that we're following our text here. So letter A here, and we've talked about this in class as well, the Appalachian Mountains, an old mountain range on the east coast of the United States. Well, it's fragmented. Part of it is here in North America. If you want to, it stops at the Atlantic Ocean, and you can pick it right back up in parts of Greenland and in parts of Northern Europe. So, this is what we mean by a similar landform that has been broken up and is located on different continents. Um, rock sequences also um, are spread across continents, rock sequences. Uh, you may be looking at sedimentary rock, a layer, uh, or some other type of rock layer from a particular time in Earth's history. And you can pick that same rock layer up over on another continent at the same place where those continents would have matched up. Okay, so this is um, looking at rock sequences compared to mountains. Um, Another thing that is mentioned is glacial sediments are distributed across continents. Sometimes when you take a look at a continent, you may not be able to, um, it doesn't make sense. Why do we see uh, evidence of glaciation at that particular spot? It doesn't make sense until you actually put the other pieces of the continents together. And then it makes sense. The distribution, you can see the complete glacial field spread across different continents. And lastly was the fossil finds. Sometimes we find fossil finds, and then we find the matching exact same fossil find over on another continent where those continents would actually match up like puzzle pieces. So, some pretty compelling evidence that has been assembled there. Evidence for plate tectonics. Okay, so what else do we have? Number one, the oldest ocean crust. Remember, the ocean crust is being formed at uh, at rift zones under the ocean, right? This is where you have seafloor spreading going on. The oldest ocean crust is only about 200 million years old. Think about that, and think about Earth's age. And can you reconcile the differences? So that could be explained, and only could be explained if, in fact, that ocean floor is being recycled continuously. And that's why the ocean floor appears to be so much younger uh, versus the age of some of the continental crust that we've been able to date, right? So, again, we're talking about evidence for plate tectonics, right? So you have this disparity between continental crust and ocean crust. The symmetrical age patterns of the ocean crust on either sides of the mid-ocean ridges. If you go down a ridge, like the Mid-Atlantic Ridge, you'll find that there's similar age in the first section of rock on either side of that zone, that rift zone. And as you go further out, and not only does the rock get older, but it gets older symmetrically on both sides of that ridging. So that's another interesting piece of evidence for plate tectonics. And then, still talking about mid ocean rift zones, you have the symmetrical magnetic reversal patterns. Remember that Earth's polarity can flip from time to time. And as that fresh magma is coming out from the ocean floor, it has a lot of iron content. It's ferrous. And so it aligns itself when it's in a liquid state. It tends to align, the iron atoms tend to align themselves along those magnetic field lines. And so, and then when they hit the water, they cool down, and we have evidence of which way Earth's polarity was at that time in history. And as you move out further and further, on both sides of that rift zone, you can see that there's a symmetrical flip flop, where we see north being near the geographical north. We're talking the magnetic north being near the geographical north, but at other times we see the magnetic north near the geographical south. So we see this reversal going on. And finally, let's move up to current day. We use GPS satellite measurements to track plate movement, which is showing an average of a few centimeters every year. All right, well, that was pretty exciting. I hope you found it as exciting as I did. And go ahead and write down your summary paragraph, and we'll talk to you soon.